let me start off by talking a little bit about, let me get this straightened out there. Last week's assignment, our welcome back program. I know several of you are new. What's the call center? That was not here. Weird. I know several of you are new. You programmed. You had other things you were doing in your programming class last semester. I know that there's some catching up to do for several of you to do to figure out how do we program in Python. And so if you didn't get it turned in yesterday, don't stress over that. I'll give some grace on this for a week or two, just to kind of give us some time to get caught up. I will say, let's see. Oh, wait a minute. This is a B day Friday. Hold on. So we only have class again on Wednesday this week because Friday is a B day. So on Wednesday in our class, which we're all going to be here again Wednesday because we meet every day for the first couple of weeks here, I'm going to focus on the basics of programming again, and we're going to look at some of that. So we're going to look at some of that on Wednesday. I want to get more into the programming. I do want to remind you, especially if you are new to the class, let me put this up on the screen. If you're looking at this first program and you're like, I don't even know where to start, it's going to do this again this week, isn't it? All right, that's better. If you have not gone to the classwork tab to the very top on how to program, then I'll bet you are lost because I pointed this out last week, and this is where you should start. Especially if you were not here last semester, click on that link and watch these videos. This is 2 minutes, 51 seconds, 3 minutes, 48 seconds, 4 minutes, 20 seconds. How to, what every program should include in programming. That means in this class, print statements in Python idle, creating and using variables, input statements, math calculations. Here's little short videos showing how to do all of the things that we've learned. But there's still a few more I need to add based on whatever suggestions you have this week. I need to add some more on here, but here are some things you need to watch if you were not in this class, and that is in Google Classroom right here at the very, very top. When you go to the classwork tab, it's the very first thing, and it will stay there at the top all semester. So how to program video series. So that's the absolute place you should start. But Wednesday, we will look at that. If you have problems programming, if there's questions you have, hey, I don't know how to do this again, even if you've watched the video, we're going to go over those type of things in class on Wednesday. So that's what we're going to spend our time focused on, is how to write programs in Python more, just because I know there's lots of new students in here that were not with us last semester that are needing to learn some of this. But this morning, we're going to go ahead and jump into Buzz and look at our lesson for the week. If we go to our grade screen, which is always the best place to start at. Last week was that welcome back program assignment due yesterday. I haven't even turned it in myself yet there, but this week we're starting our curriculum 4.01. We're going to learn about decisions in Python, how to have decisions, program for decisions in Python. So we're going to start and look at that today. And like I said, we're going to focus a lot on programming on Wednesday. But if you have specific questions on programming, you can go ahead and throw it in the chat, and we'll address that as time allows before we get out of here. But let's go over to our 4.01. So back on the activity screen, if we scroll down to module 4, the decisions lesson. We're going to take a look at that this morning. Now remember, from the lessons, if you're trying to write a program, this is where you find your programming window, right here at the top, this menu, idle. When you click on that, it opens up, and it's not showing you because of the way I'm presenting it. It opens up this window right here, and this is where we write our code. Write code here, which I run, and that's an error because that's not any kind of code right there. But this is where we write our code. Yep, this little idle button at the top is where you find the coding window. That's step one in writing any program, is knowing where to write the program. But that's it. All right, let's look at the lesson. The power of if. To be or not to be. Yeah, that's an easy yes or no, right? You want to be? You don't want to be. True or false? You decide. Right? The power of if, what we're talking about today, the power of if lies in your ability to make a decision. If the stove is hot, you can decide not to touch the stove. If you're old enough to vote, it's your choice. You can go vote, or you can not go vote. If you want to know what happens to Hamlet, you can see the play or read the book, or not. You got to make that call. So we also can write code that tells a computer what decisions we like to make and when to do that. So we're going to be able to explain how if statements are used. We're going to identify relational operators and demonstrate the use of Boolean logic for if statements. Page 2. So sometimes you make decisions based on emotions or just gut feelings, but other times you use logic. Hopefully a lot of times you use logic. Computers don't have emotions or gut feelings, so they only have logic. In fact, logic is one of the most powerful tools that programmers can use. So the source of this logical programming lies in one simple word: if. So if you think in terms of a condition and a consequence, then this lesson should be a cinch right here. So let's look at this. Flip over each card to see what happens if a condition is true. So condition: if you want to see a concert, then what? Then buy a ticket so you can go to the concert. So decision statements are based on condition statements that start with the keyword if. Oh, this applies to us right now. If it is cold, then dress warmly. Right? Don't wear our shorts and a tank top. If the condition is true, like it's cold, then you want to take an action. You want to dress warmer. If you like spicy food, then eat it. But if not, then don't, right? If the condition is not true, then you do nothing. You don't eat the spicy food. You move on to eat dessert first. Page 3. That's the basics of how an if works in life, right? And we're going to do the same thing in programming. So programmers use relational operators to tell the computer to search for logical connections between items. So you're familiar with these from math. Math is highly related to programming. So let's see some of the ways you use logic in real life. If true, then what? If age is what? 18, then you can vote. So we have an equal. Now, remember in Python, if we're checking to see if something equals something, you got to use 2 equal signs. 1 equal signs mean you're assigning a value. Name equals Bob, right? But if we're saying if name equals Bob, we got to use 2 equal signs. So which one do we need to see? If age is equal, greater than, less than or equal to, less than, greater than or equal to, or not equal to. Remember in Python, an exclamation followed by an equal sign means not equal. So if age is greater than or equal to 18, right? Greater than or equal to. It's not just equal to 18 because 19-year-olds can vote too. And it's not just greater than because 18-year-olds can vote. So if age is, and we need to use greater than or equal to 18, then you can vote. Submit. All right. If water is what? 100 degrees Celsius, it has reached the boil point. If it is equal to, if it's equal to 100 degrees Celsius, that's correct. It's not greater than or equal to. It's reached the point when it hits 100. At 101, 102, it's past the boiling point, but it's saying it's reached. So look at the statement, look at the logic that goes with it. If height is blank 48 inches, you cannot ride the roller coaster. It's a sad day. Or if you want to ride Wildfire, I think it's 54 inches. You got to be taller for the loop roller coaster. If the height is less than, right? Because if you hit 48 inches, you're good. But if it's less than 48 inches, great job. Your sensors are quite impressive here. If data usage is blank data plan, you pay an overage fee. So if you don't have a wireless that has like endless data, if you pay for 3 gigabytes and you use 3.1 gigabytes of data on your phone plan, if data usage is greater than your data plan, then you pay fee for the extra data you used. Great job. If your online profile is blank real identity, then you've probably been catfished. Oh, let's see. What do you think? Not equal? If online profile is not equal to the real identity? Yep. If driving speed is blank speed limit, you will not get a ticket. Less than or equal to. I think not just less than the speed limit. You can be equal to the speed limit. Less than or equal to. And our last one is, just a score. We got 100%. So we need to know how to use relational operator. If you struggle with that, go do these yourself. Go to page 3. Go through these things. So an if statement in programming here tells the computer that if a condition is true, then the computer should execute a block of code within it. If it's false, then it just skips everything that's in that loop. You have to arrive at the fair. If your height is greater than or equal to 48 inches, yes, you ride the roller coaster. Otherwise, no, you just go get ice cream. If it is, you go ride the roller coaster and then go get ice cream. So height equals 48.5. If height is greater than or equal to 48, print, you can ride. So this says, yes, you can, because you're 48 and a half. It uses Boolean logic. So you're either tall enough or you aren't. It's that simple. When we went to Disneyland in California, when my kids were little, my middle daughter was 6 years old at the time, and she had tennis shoes that had tall heels just to make sure she was right at 48 inches, because sometimes they'd measure and she'd be just a little bit below and she couldn't ride, and it made her mad. She wanted to ride all the roller coasters, and so she had tall tennis shoes that she wore to the park that got her at the 48-inch mark so she could ride roller coasters. George Boole, let's take a look at George Boole here. He was in the 1800s. He lived from 1815 to 1864. A lot of people died younger then. He was like 49 when he died there. Most specific Google searcher. And we give him a title here. This English mathematician is credited with laying the foundation for the information age. He was the inventor of Boolean logic, thus the name, because George Boole was his name. He developed the basis for what computers now use to make decisions, the condition statement. Without him, you would never be able to search videos with cats and teacup pigs or sloths. You're welcome. Because that's Boolean logic. With cats and teacup pigs. So it would have to have both, or it could have sloths instead of pigs. Boolean logic. All right, let's look at some samples on how this works in Python. Precision and practice. It's true that the if statement is one of the most powerful tools a programmer has, but it also can cause a lot of errors if you're not doing it correctly. If you're not used to thinking with Boolean logic, you're likely to run into confusing problems along the way. Don't worry, this is all part of being an experienced programmer. The more you practice with if statements and Boolean logic, the better code you can write. So let's give if statements a try here. Follow the instructions and complete the activity. Especially if you're new to this class, this is an important thing to do every week. Go to this screen that has the Python window, and here is a program written over here, and this is where you can practice. You can practice with all of this. You can practice with all of this and change code to see what happens. Run their code. Read over here. This tells you what you do. Read over the code, predict the output. Then run the program and look at the output. Was it what we expected? Then it wants us to change the values of A and B. and then see how the output changes. So this is a great place to start when we're going to write a program, is to go look at the lessons. See, what did they do? How did that work? How does that program work there? By the way, I'm seeing your guys' messages in the chat. Thanks, keeping me updated. So let's look at the code and then try to predict the output. So we first have our main statement, which we should start everything with. Define the main statement here. A equals 20. B equals 30. So we have two variables. One's called A, one's called B. Those are not good variable names because A and B can be anything. We should really say A, instead of A, we should say like num1 or number 1 or num2, number 2. Give us a name that means something. These are not good examples, but we'll use A and B for now. And it has print, facts about A and B. So that's going to print to the screen. If A equals B, remember we've got to do the 2 equal sign. We did 1 up here because we were assigning a value to A and B, 1 equal sign. But say if they're equal, then it's going to print A equals B. If A is not equal to B, it's going to print A is not equal to B. If A is larger than B, it's going to print A is greater than B. If A is larger than or equal to, it's going to say A is greater than or equal to B. If A is less than B, it's going to print A is less than B. And if A is less than or equal to B. Now notice we have multiple if statements here, and it could print 6 different things if all that was true, but it's all can't be true, right? Because some of it says greater than, some less than. But what do we expect it to print? A is 20, B is 30. So are they equal? No, we expect it will skip this line. Notice in the if statement, we indent 4 spaces there. It is indented. Everything that we want to happen, if A equals B, everything we want to happen needs to be indented underneath the if statement. There's only one thing under the if statement. So it's only going to do one thing if that's true. Now, in this case, A is 20, B is 30. It's not going to do this one. A is not equal to B. Okay, we should expect it to print this line because they are not equal. Is A larger than B? No, we expect it to skip this line. Is A larger than or equal to? No, it should skip this line. A less than B? Yes, 20 is less than 30, so it should print this line. Is it less than or equal to? Yes, it should print this line. So it should print 3 things. They're not equal. A is less or equal. Let's run it and see what happens. Facts about A and B. A is not equal to B. A is less than B. A is less or equal to B. There's the 3 statements we expected, because those are the 3 if statements that were true. It totally skipped the print statements when the if statement was false, because A was not larger than B. All right, now it wants us to change the values and see how things change. So let's do this. Let's make them equal. Let's make both of them, let's say 25. A and B are now the same. This should print because A does equal B. This should not print because that's if A is not equal to B. This should not print because it says A has to be larger than B, but this one will, larger than or equal to. Less than should not print. This one should, less than or equal to. So let's run the program. A equals B. A is greater than or equal to B. A is less than or equal to B. That's 3 we expected. What if A is 25.01? Not equal. A is greater than or equal. Because A is larger by 0.01. So you get an idea how if statements work. It just simply checks some condition, and here's the condition. And if that's true, it's going to execute the code that is underneath it that is indented. That is indented. All right, let's look at the next example. Define main, age equals 20. If age is greater than or equal to 18, print, you can vote. Now notice how the if statement works. If we have to put the condition in parentheses, we have to use the Boolean logic, and we have to have a colon at the end. If you forget any of those pieces, you're going to have an error, right? So it says, all right, experiment with this program by changing the values of ages like 17, 18, 25, and look at the output each time. All right, so right now we've got age 20. Let's run it. You can vote. Your age is 20. All right, let's change this to 17. Nothing happens. Nothing. We don't even know if we ran the program, right? Nothing happens. Because the only thing that's going to happen is if age is greater than or equal to 18, it prints. Otherwise, there's no print statement. So we don't expect anything to come on the screen. There's nothing there. Change this to 18. You can vote. So as long as this is 18 or larger, it's going to print something. If it's not going to do anything because we didn't tell it to do anything in the program if this is not true. All right, let's look at slide 3. Num days absent, 0. If num days absent equals 0, print you have perfect attendance. Okay, read over the code, predict the output. Let's run. Bad input on line 6. Oh, what's wrong? Anyone have an idea? I'll give you a second there. I'm going to look at the chat. See if you can figure out what's wrong. Why did this give us an error on line 6? Anyone figure that out? Because when we look at it, right off the bat, we're thinking, well, it's got the colon at the end. Oh, Braylon's paying attention. Great job, Braylon. We use one equal sign to assign a value. If we're checking with Boolean logic, we have to use 2 equals equals if num days equals. So this is how we actually check it. This is how we assign the value up here. So let's run it now that we've added a second. You have perfect attendance. See, it printed that there. You need 2 of them. If you only have 1. Now, if you notice, it does give you a hint down here if you were paying attention. But make sure you call an extra function. They got to have 2 relational operators to test. So it does give us some help down there. Fix the error by using the relational operator for equal to. Equal to is 2 equal signs. Perfect. Okay, let's look at slide 4. Define main. Cost equals 20. So we've assigned the value 20.00 to the variable cost. And we've gave it a discount equal to 0. So we've assigned the value 0. And on sale, we've assigned a Y, the string letter Y. If on sale equals Y, then we're going to change the discount to $2.85. The cost is going to be the cost minus the discount, which the cost is $20. It's either going to be 0 or 2.85, depending on whether or not it's on sale. Print, the cost is $sign. Notice the $sign's inside the quote because we want to actually print a $sign on the screen. And then cost. And since cost is a number and this is letters, and Python does not like to print letters and numbers together, we have to tell Python, hey, pretend this is just a string of letters. Remember, that's what we use that str for, to print letters and numbers on the same line. And that's the end of the program. So let's run it. Cost of $17.15. Because when it got to this loop, on sale was yes. On sale was yes, so it discounted $2.85. If we change that to no, right, on sale equals in, no, run it. The cost is $20. It did not subtract anything for the discount. Now, here's an error we run into sometimes. On sale equals yes. On sale equals yes. Let's run it and see what it says. Look, the cost is $20. Run. See, I'm hitting run. It did not give us a discount. It still charges us the $20. What's going on? Yes is not the same thing as Y. If we want to actually put yes, we got to put yes here. Now the discount is applied, and it's $17.50. Yes, it's not saying things are why. Okay, let's look at the last sample. The if statement, define main, print. Let's go to the movies. Ticket cost $10.25. Boy, it must be a matinee because movies are, they should be like $12 or something, right? $7.25. Snacks. Right now we're setting snacks at 0 because you haven't ordered any. Here's an input statement that will pop up on the screen. Popcorn, Y or N. It's important to, as we just looked at in that last screen, it's important to put Y or N because if they type yes, and when we check here, if popcorn order equals Y, if we type yes, it's going to skip it. It's going to say you didn't order anything. So it's important to put in your input statements, what do they need to type in? If you're using an if statement, you need to put in the choices what they need to type exactly. Do they need to type yes or no, or do they need to type Y or N? Because our order form is looking for only a Y. If order popcorn equals Y, then give them a snack cost of $3.75. Whatever the snack cost was, because maybe they ordered something previously, add $3.75 to it because that's how much we're charging for the popcorn. It must be a child-sized popcorn because otherwise it's like, what, $8 or something for popcorn. So the total cost is your ticket plus how much you spent on snacks. So print, cost of the ticket is this much, cost of snacks is the snack cost, and then print the total cost on there. So let's see. When I hit run program, it pops up this window. Popcorn, yes or no? If I hit yes, go to the movies. Cost of ticket, $7.25. Cost of snacks, $3.75. That'll be $11, please. How about we hit run program and hit end? No. Now it's cost of ticket, $7.25. Cost of snacks, $0. Total cost, $7.25. And then as we talked about earlier, what if I say, yes, please? I typed yes, please. And I got no snacks. Also snacks, 0. That's why we put that Y or N up there to let them know. Make sure you hit the Y. Don't hit yes. Don't hit yes, please. Don't put yes. I would like a big helping of popcorn with butter on it. $3.75. Total cost $11. All right. So that is the sample program to give it. This week, we do not have a program to write. We just have a 5-question quiz. Go look at the 5-question quiz. Here's the assignment this week. Relational operators compare values, determine whether a condition of an if statement is true or false. Is that true or false? Which means less than or equal to. Oh, that's good to know. Which is equal to. Which of the following is an example of a Boolean condition that Python would recognize? Which of the following if statements uses a Boolean condition to test if the item's on sale, you can buy it? All right, 5 questions. That's all you have this week. So we're learning about if statements, which means guess what we're doing next week? Next week, we're writing a program that uses if statements, right? So when we learn something this week, that's why you should go in there on that page 4 and play with the sample program, because next week you're going to need to write a program that uses an if statement. So these off weeks that we just have the 5-question quiz, you're like, oh, I'll just take the quiz, I'm done. No, you should really go into the practice lesson. You should go into the lesson and practice on page 4 and play with those things. Maybe even start writing your own program if you want to, just to see how it works. Let me see if I can write one. Click on that idle button to open up the programming window and play with it. The only way to get good at programming is to program, not just reading about programming. So that's why you need to spend time doing those things. Short week, just 5-question quiz. Not going to take you long to do that. And remember, if you bomb the 5-question quiz, you can retake it. Buzz will let you go redo. But pay attention. You shouldn't struggle with that. If you need to go back and reread the lesson again, it was only 4 pages. Page 5 is just saying go do the quiz. So we can do that. But otherwise, talk a little bit about last week's program. Last week's program didn't have an if statement, unless you would add one in there. If you're looking at this week's already, that's fine to add one in there. But let's go back and look at the requirements of last week and see if we can provide a little help on that. Welcome back, programming assignment. Put it up on the screen there. All right, in Python idle, we always have this name, date, short description program at the top. You have to use indentation or it's just going to give you errors. So I really shouldn't even have to put that in the instructions, but you got to indent things properly. You can use white space. What I mean by white space, that's a good question. Let's switch over here to a programming window. And that's saying right here, where if I go hashtag Mr. Brock, hashtag 12, 11, 25. Oh, I hit an extra number in there. Hashtag this week's program or whatever it is. Define main. Print. This is the start of my program. Input. Oh, let's see. Variable name equals input. What is your name? Quote. Print. Hello. Plus name. Name. All right. What does that mean? Use white space. Well, I mean, this is okay, but the longer the program gets, it's a little tougher to read. But I can put some spaces in here to kind of space things out a little bit. That makes it a little easier to read now. Okay, here's the beginning of the main function. First thing it does is just print the start of my program. Then we got an input, and it's going to print what they enter. Run program. I'm Bob. Hello, Bob. Started my program. Putting white space. Python doesn't care if you put blank lines in there. It totally doesn't care one way or the other. You can put the blank lines in there. But when you're reading a program, sometimes it's easier to have these extra spaces in there. And that's what this means when it says the use of white space in your program. Just make it easy. You'll group things together. But then if you're starting something different, like right here, this was just printing the start of my program. But then I'm going to do an input with a print. I put a little space in there just to separate it, make it easier to read. So that's what that's talking about. Make sure your program contains the main function. I did right there. Define the main function. Main. If you don't have this at the end, it won't run your main function. So this should start your main function. This should be at the end to run your main function. Use meaningful names for all variables. See, I said name equals. I didn't say X. X equals, and then print X. See, that's not good. Variable X could be anything. Like, is this a number? Is it what am I doing? I mean, it works just fine. Bob still prints hello, Bob. But this should be something that means something. The variable should be something to help you understand what that variable is. Okay, well, that's their name, obviously, because I called it name. Use at least one input statement. Oh, I've already done that. I did an input statement right there. Ask them what their name was. I haven't done a math computation yet. One line of code that does some kind of math. At least one print statement. I've done that. I haven't done a for or while loop. I need to go back and review the for loops, right? Insert your pseudocode where you're playing out your program. I mean, I could say for loop and for count and loop 10. Total equals total plus count. Where I'm just here's my math computation. I'm putting it in my loop. And then when I come out of my loop, I'm going to print the total. See what that does. Bob. I did something wrong there. What is that? I messed up the loop statement. Let me go back and look at for loops. I know I was doing something wrong. For loops. I'll go back and look at the for loops lesson. We get this error. That's why I leave all the old lessons from last time. I'm going to go to page 5 because usually there's sample programs on the last page. Oh, range. That's it. Not loop. Range. For count in range. I want it to count 0 to 9 and stop when I get to 10. Bob. Uh-oh. What this said? Unbound local error, local variable total reference to. Oh, see, I never gave it a total. Total equals 0. I need to create the variable. Set it equal to 0. Now it can add the count on there. 45. Create the variable total, set it equal to 0. And then as it goes through this loop 10 times, it will add up the total of all the numbers. And it adds up to 45. You're like, is that right? Well, remember, it does not count from 1 to 10. It counts from 0 to 9. So let's say print 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. Let's see if it's right, because that's what it should count right here. So it should be the exact same total. I can put a space in there or not, just to make it easier to read. Grid 45, 45. Yeah, see, it did count from 0 to 9, because that's what 0 to 9 equals, is 45. And that's what I did. If I want this to count from 1 to 10, I can say, okay, start at 1, count to 10, and go by ones. 1 to 10 by ones. Now, oh, it's still at 45, huh? Or 1 to 11, because I got to stop at 11. It went from 1 to 9, basically. This is the number that kicks it out of the loop. So if I wanted to count from 1 to 10, I tell it, when you get to 11, stop. Stop at 11. So from 1 to 11 by ones. See, now it gets to 55. We took 0 out. We could have left 0 in. It doesn't really matter. 0 doesn't change our total. But that counts from 1 to 10 now. 55. But this basically meets everything that program needs right there, right? We've go back to the assignment here. We've got an input statement. We did math. We added to the total all the time. We did a print statement. We did a for loop. We just haven't written the pseudocode. Haven't written the pseudocode, which there is a lesson way back here about a pseudocode. Is it printing strings, string input? One of these talks about some pseudocode pretty early. And I'm going to make a video on pseudocode. So if you don't know how to write pseudocode yet, because you're new this semester, we'll get there. I think it was in an earlier lesson. Pseudocode is fake code. It's just where you write your plan. And I left all these old lessons in here that we went over before, so you can go back and take a look at those. But I'm also going to make a video to put in our how-to program video series on pseudocode, just simply on there, just so you have that. But anyway, all right, Wednesday, we're going to talk more about programming, the actual how-to. So if you're new to the class, I just showed you a little quick program I wrote that did everything required in there, but you need to go in there and actually start trying to program. And if you run into errors, that's what programming is. We run into errors all the time in programming. It's learning how to correct those errors. But anyway, make sure you can log into Buzz, get this week's lesson done. Even if you haven't written last week's program, get that 5-question quiz done. And let me know if you have problems. I will see you on Wednesday, guys.